Welcome to E-Padasala PG program for computer science students. Today we will be talking about programming the parallel ports in embedded systems. So, in this course we will be looking at the pin diagram of 8051 controller, and we will be giving a certain introduction towards the ports of 8051 controller, and we will be writing simple assembly codes to handle the ports and pins of the ports, so that we will be developing certain applications. So, in this actually when you are looking at 8051 microcontroller, we will be having a 40 pin chip. In that 40 pin chip, the 40th pin and the 20th pin is the VCC and ground, and we have 4 parallel ports. In that parallel port we will be using it, 2 of the ports will be used for sending your address as well as your data, receiving data or sending data to memories or different input output devices, and other 2 things can be used for interfacing with input output devices, and one port is specially, it can be used for input output as well as it can be used for some special purpose also. So, that port 3 is used for special purpose also, and other than this 4 parallel ports, in the parallel port, in the sense we will be having 8 bit in a single port. So, in this other than this 32 pins, we will be having something like reset pin as well as your address latch enable pin, and you will be having a program strobe enable pin, and the other external crystal oscillator pins. So, these pins we will be having around some 40 pins. In this particular course, section, we will be looking at major on parallel port as a, communication between input output devices through your parallel ports. So, when you are looking at the pins, we will have VCC, we have to give 5 volt supply, and VSS is your ground pin, and we have 2 crystal oscillators from the oscillators will provide the clock inside to your microcontroller. So, XTEL1 and XTEL2, these 2 are the oscillators, these are the inputs provided at these 2 pins, and we have a port 0 and port 1, where this port 0 the pin is from 32 to 39, and this will be a multiplexed pin where you can use it for address as well as data, and your port 1 will have from 1 to 8, first pin to 8th pin will have a port 1, and port 2 21st pin to 28th pin, and these 2 also will be this port 2 is also used for sending address to memory. And when you are looking at the RST pin, this is for restarting your 8051. If something happens, we can restart the 8051, for that they have given that particular pin, and we will have a port 3 where this port 3 is available from pin number 10 to 17. In this actually this port 3 is a very special port where each pin is having multifunctionals. So, we will see that in a detailed way in the next slides. Maybe the other things we will cover now. If I am looking at the ALE, we know that we have address and data combined together, we have multiplexed pins are used because we have only 4 ports to use for input output devices as well as addressing. So, because of that we used one port is a multiplexed port where I can use it for address as well as I can use it for data. So, the ALE is always used to find out whether the pin is that port is used for either address or for data purpose. For that to understand whether it is used as a address port or a data port, then we will be using this ALE pin. So, there the ALE pin will be giving you something like address latch enable, where this one, if I am providing a 1 at that particular pin, then I will say that addresses will be sent through that particular AD0 to AD7. If I am providing a 0 at ALE pin, then it tells that the data will be sent through that AD0 to AD7. And we have another one pin which is program strobe enable, where if I am setting that, if that particular pin is 1, then only I can be able to read the program from outside memory. So, next we will be covering about your ports, where when I am looking at ports, we have 4 ports in your 8051 that we have seen in the pin diagram itself. In that particular 4 ports, we can use for inputting a data as well as outputting data. you can read the data from outside or you can send the data to outside also. So, when you are having a latch, these pins, I mean this ports will have a latch and there will be an input buffer. So, when you are using a latch, maybe you will be sending a data outside, and the input buffer, when you wanted to read something, there will be a input buffer is also used. P0, P2 is used and your P3 will perform special function also. So, the output drivers for port 0 and port 2 and the input buffers P0 are used to access the external memory. That means, sometimes as we have gone through this microcontrollers having its own memory, but it will be of a very lesser space. So, that may not be sufficient to hold the data. So, by the time either the program or the data will be, I mean you can read it from external memory or you can write it to external memory. So, by the time we can use this port 0 to port 0 and port 2 for sending your data as well as reading a data and reading your sending your address and all those purposes we will be using it. So, port 0 outputs the lower byte of the external memory address and the time multiplexed byte is being written or read. So, when you are looking at, I mean the pin diagram itself gives us a very good picture about multiplexed address data. So, when you are looking at your port 2, the higher byte of your external memory address. So, if I wanted to access 16-bit address of a memory, then port 0 and port 2 is combined together and the address is sent. So, port 3 is having a multifunctionals. So, one is actually your port 0 and port 3. In port 3 the pin 3.0 and 3.1 are used for serial port communications. That means, RS-232 communication can be achieved through this particular pins. So, this 8051 is used for not only used for only parallel communication, it can support the serial communication also. So, and your 3.2 and 3.3 pins, this will be used for your interrupts. So, external interrupt can also be accepted by this particular pins P 3.2 and 3.3. So, 2 interrupt pins are supported, and your P 3.4 and 3.5, there are 2 pins where you can use it as a counter also. So, if I am thinking that I wanted to count something happening outside, that can be given as an input to these pins, so that I will count it how many times that particular thing has happened. And your 3.6 and 3.7, this will be for external data memory write strobe and read strobe. If I wanted to read it from external memory, if it is internal memory, nothing is needed. But if I am looking at external data memory, then either I wanted to write it or I wanted to read it, then I have to send it through this particular, these are the 2 control things which will be useful to read and write from your external data memory. So, this pins can, if I am not using all these things, I can use it as a IO pin also for a IO purpose also, this particular pin port. So, when you are looking at the ports, usually all ports will be configured as input ports. So, if I am resetting anything, if I am starting at first, it will be acted as a input port only. So, when the 0 is returned to the port, it has been, if I am writing a 0 to that particular port, then I will say that it is an output port. If I am configuring this port with an input given as 1 to be returned to this particular port, then I will say that this is an input port. So, if I wanted to use a particular, for a particular application, if a particular port or a pin has to be used as an input, then always I should start with the 1 should be sent to that particular pin, or 1 should be sent to that particular port. That initiates or we can declare that particular pin or port as an input pin or input port. So, when I am looking at maybe this is a simple program segment where I will be in a position to configure a particular port as an input port, and I will be reading it. So, now you just see that this is an example code where it is a part of a code where I can see that a port 0 is configured as an input port by sending a 8 ones, rather I can call FF. So, if I am sending a 8 ones, then it will be configured that particular port as an input port. So, now this simple code gives you, first I have moved move a comma hash 0 FFH. So, what I am trying to say is this FF is a data, immediate data, and it is hexadecimal data which is sent to your A. Then move P naught comma A, what it says is I am moving the data from A to P naught. Now I am sending this FF to P naught. So, which in turn says that the P naught is declared as a input port. Now, move A comma P naught, what is the process taken at that particular time is, whatever be the data which is available in your P naught will be read and it will be sent to your A register. Then now this A is moved towards P2, maybe P2 is not declared. So, this has been treated as an output device. Maybe port 2 is taken as an output port. So, I can read whatever be the data which is given at my P naught I have read and I am sending it to P2, that has been done at this particular thing. But one thing has to be noted out over here is when I am giving a 1 to P naught, then it will be written, this will be informed to the code or the device in such a way that P naught is a input port. But after that this P naught is receiving some other data from outside, because some input device is connected to P naught. Because of that, P naught is no longer having a value of 1, and see, remember here move P naught comma A, there 1 is assigned, but now in this particular statement we read A comma P naught, that means P naught content is moved to A. It does not mean that this FF is moved to A now. By the time if the P naught is connected to some input devices, then whatever be the data which is read by your P naught is given to your A. Now, that A we wanted to display it at P2, so we are transferring it. So, this is for only declaring P naught is input port, and now we are reading the data which is given to A, and A content is moved to P2. This is what happened when you are looking at the port reading as well as port writing. We will be accessing the ports as input ports as well as output ports. When you are looking at the port 0, the AD0 to AD7 is assigned for your port 0. So, it can be used for both address and data. So, while you wanted to configure the external memory, then the port 0 provides both address and 0, and port 1 is used as input and output. Upon the reset, P1 is configured as input port. So, now the port 2 is also used as input and output, whereas the reset port 2 is configured as input port. So, the port 2 along with your P naught will provide a 16-bit address for the external memory. Maybe if I have an external memory which needs 16-bit address, then P naught and P2 is combined together to provide the address for that, but for accessing the or reading the external memory. Now, port 2 is giving you the higher order byte address, and the port 0 is giving you the lower order byte address. So, now you just see that we have gone through all the ports and how we will be declaring the ports as an input port or an output port, and what way the external memory can be accessed with the data and address bits. So, that we have gone through, but now we need to know that not only the port, single bit also can be addressed or accessed or processed in this particular 8051. So, this can be done through this kind of statements where set B, which tells you that whatever be the bit. For example, if I am making it P3.1, then set B P3.1 says that P3.1 equal to 1, and that means I am setting a bit, the B tells you it is a bit, set tells you it is equal to 1, and whatever be the address I am giving it, there it will be assigned. So, clear a bit, maybe if I am giving it clear P1.0, then P1.0 pin is equal to 0. So, clear is or reset is done through this particular CLR command opcode. CPL is nothing but complement. So, if I am giving a particular P3.1, then CPL P3.1 what it does is it changes from 1 to 0 or 0 to 1 of that particular bit. These are all bit operations done through this kind of commands. JB, these are all operations. This is actually jumps which this is a conditional statements are the jumps which occurred based on whether the bit is 1 or 0. So, if JB what it says is jump to target if the bit is equal to 1. Jump the bit if P1 maybe the bit is P1.1 and target is somewhere loop, then if P1 3.1 is equal to 1, then go to this loop. that is what it is trying to say. So, jump to target if bit is equal to 1. JNB, what it says is jump to target if bit is equal to 0. So, JNB is no bit. If there is no bit that is equal to 0, then which is the address I have given, then go to this particular target. So, JBC, this is actually jump to the target if bit is equal to 1, after that you clear it. So, that C says that clear the bit after jump. If the bit is there, you jump it and clear that particular bit. So, this is what happens when you are looking at single bit operations. So, if I wanted to access only 1 or 2 bits of the port, then I can use this whatever be the comments I have given. This is the examples of those comments. So, CPL P3 P 0.4 tells you that port 0 4th pin is complemented. If it is 0, then it goes to 1. If it is 1, it goes to 0. So, when I am looking at set B P 1.4, then it says that P 1.4 pin is getting set, that is equal to 1. So, clear P 2.2, what it says is it clears that particular pin. Whatever be the content it is there, it has been sent as 0 to P 2.2. So, set B P 1.0, what it says is the P 1.0 bit is set as 1, that means high. So, this is what happens when you are looking at the pin wise will be operating through your opcodes. So, now we have gone through a single bit operations as well as we have gone through the how we will be accessing the ports. Now, these instructions are used to monitor a single bit, and based on that we can take a decision whether what is the process we have to do if it is equal to 0 or if it is equal to 1. So, now you just see that this is an example where I wanted to generate, that means see with these ports and pins we can develop applications through this 8051 microcontroller. You just see that this is an example code to generate a square wave with your 8051 port. So, here what we have done over there is first I will be setting up P 1.3. So, what it says is P 1.3, if I am setting it, what it says is it has been equal to 1. That means you just see that if I am looking at a square wave, I will say that this is high. So, high in the sense this is high and this is low. So, high is high in the sense I will say that it is 1. I am retaining the value of 1 for certain time, then I will give a value of 0 for certain time. So, if these two times are similar, then it becomes a square wave. If these two times are different, then it will look like a rectangular wave. This is for a single step. If I am looking at if this has been generated continuously, then I will be in a position to generate square wave or a rectangular wave. Now, this is a simple segment using which I have generated a square wave. So, here for example, this is 8051 microcontroller and this is a pin where I am taking my output. Because I am taking an output at this particular point, I am not initially I am not setting it, it is an input port, it is an output port. So, if I am not setting anything, then it becomes a 0. So, I will say that it is an output port. So, now loop is a tag, I have placed it for jumping up, and set B P 1.3. So, now set B tells that I am setting P 1.3 pin is equal to 1. Now, I have set it for 1. L call delay. So, what I am trying to say over here is I can say it is a subroutine called for making a delay. This delay is a routine. L call is telling you that it is a subroutine long call, that means this delay subroutine is written somewhere far away. So, that I will call it long call and I will go to that particular subroutine, I have to run that subroutine, I have to come back. So, there I would have not been processed anything, but instead I will make some delay statements, I will be putting a loop. So, I am not doing any work. Now, after that particular delay, maybe the delay occurred up to this particular time. So, after that clear P 1.3. So, clear is telling you that P 1.3 is set to 0. So, this has been put to 0. Now, it comes to 0. Again I am calling the same delay subroutine. So, that particular delay where the same because these two are the similar delays I called. So, this particular delay is executed for the similar time of this only. So, now this time and this time are similar. Now, we will be getting a 1 for certain time and 0 for the same time. After that I am making a S jump loop. So, S jump tells you that short jump to loop. So, now it comes over here, again it will be set to 1, P 1.3 is set to 1, and I am again calling a delay. So, delay retained for this time, again I am clearing it, that means I am setting it to 0, I am retaining it for the same time. So, now you just this gets repeated, because again a S-jump loop. Now, this loop is getting rotated for indefinitely, that means I am generating this kind of square wave, square waves continuously. So, now if I wanted to give this square wave to any of the devices which I needed, I can directly connect this pin to that particular device. So, this is the way an application can be generated, that means a square wave can be generated. This 8051 can be used as a square wave generator with a certain delay. So, any applications I can develop with my 8051 in a pin or a port using this kind of assembly codes. Let us see sample program, maybe that will be quite interesting also. So, now I have given a simple program where a switch is connected to pin 1.7. You just see that I have taken pin 1.7, there is a switch is there, and I wanted to write a code. I will be looking at the status of the switch, whether the switch is pressed or released. So, if the switch is pressed, I will say that what has to be done. If the switch is not pressed, what has to be done. So, I can say that if it is switch is pressed, in the sense I can say the switch is equal to 1. Then I will send a S to P2. P2 is a port, I will send a parallel port, S is the value. So, S is a 8-bit 1 byte word, that will be sent through my P2. If the switch is not pressed, I can get receive SW is equal to 0. Then send a letter N to your port 2. So, now you just see that this is an application where if I am pressing this button, I should send S to P2. If I am not pressing this particular button, then I should send a N to P2. This is what the application I wanted to generate. Instead of sending a N or S, you can do some other applications also over there. So, this is a code which will do this particular process. So, now you just see that first I made it set B P 1.7. So, this pin I am thinking that I am declaring it is a input pin. For that particular reason I made it set B P 1.7, which makes the pin 1.7 declared as input pin. Then again this is again is a tag where the JB jump on bit P 1.7 over. So, now if I am just continuously I will monitor the pin is 1.7, I will be looking at whether the pin 1.7 is 1 or 0. If it is 1, then I have to go to over, I have to come over here. If I am coming over here, I have to make move P2 hash S. So, because it is a immediate addressing, S is a character which is of a 8-bit length, which will be moved to my parallel port P2. So, S is moved to P2, S jump again I come over here. I have to see that if the bit is not equal to 1, that means the JB P 1.7 is fails. If JB is P 1.7 is not pressed, that means the switch is not pressed in the case, JB P 1.7 now takes a value of 0 only. So, if it is 0, then this condition fails, JB P 1.7 fails, so it comes down. So, when it comes down, I will be looking at move P2 hash N. So, now the N is moved to parallel port P2 and S jump again I am coming over here. So, based on whether it is pressed or not pressed, I will be sending, if it is not pressed, I will send a N to P2, if it is pressed, I will send a letter S to P2. So, it is a very simple program which demonstrates you how to read a particular pin, how to access a particular port. So, now we will go ahead with another one interesting example code which access your ports and pins. Here this is a problem. I have a switch which is connected to P 0.1, and if I have to look at that particular pin, see for example, if it is a washing machine, if I am pressing it, it has to work, if I am not pressing it, it should not work. So, here I will keep monitoring this particular switch, whether it has been pressed or not pressed. So, when I am looking at this particular one, now what I have to do is I have to keep monitoring this particular pin, whether I will be in a position to get the switch is pressed or not pressed. So, I will get either 1 or 0 over there. So, till I am not getting a 1 over there, I have to be looking at this particular pin only. So, now just see that keep monitoring the switch at P 0.1 until it becomes high. Okay, I have to make a indefinite loop until I have to make a loop till I am getting a 1 at P 0.1. Then P 0.1 becomes high, the LEDs which is connected to port 2 has to be lighted and send a low to high pulse to your P 1.2, which in turn sounds a buzzer. This is what I wanted to have. If I press the switch, the LEDs has to glow, which is connected to P2, and there is a buzzer which is connected to P 1.2 pin has to give a sound. This is what the program segment we wanted to write with this particular one. So, now set B P 0.1. So, this makes that it is an input pin. Next, I am moving my A is equal to FF, then FF in the sense I will be having something like 111 series of 1s over there. Now, JNB P 0.1 again. So, what I am trying to say over here is till it is not bit, jump on no bit again. So, it goes in a loop till I am getting a 1 at P 0.1. Once I am getting a value of 1, it comes down. Then move P2 comma A. A is having a value of 111 which is given to P2. Now, you just see that all the LEDs are connected at P2. So, if 1 is given over there, all the LEDs will be glowing, and clear P2, set B P 1.2. So, what it is trying to do is low to high pulse we wanted to give. We do not want to give either 1 or 0 to avoid the spikes. I am giving first a low pulse, then I will be giving a high pulse. So, low to high is given at P 1.2, which in turn makes a buzzer to sound, and S jump again. So, it comes over here again, it will be doing the same process. So, now you just see that by operating your ports P0, P2 and the pin P 0.1 and pin 1.2, we will be making a particular application, so that if switch is pressed, the LED should glow and the buzzer should sound. So, this is the way you have to attach any of the applications along with the pins and ports. So, it has to be written properly, so that it will work to do that particular application. So, in this actually section, we have discussed about the pin diagram of 8051 microcontroller, and we have given certain introduction about your ports as well as the pins of the controller, and how to operate the pins and ports with your 8051 controller, so that we will be in a position to develop simple applications. That also has been demonstrated in this particular section. Thank you.